All right, let's talk about something we've all run into. You're deep in your code, and you realize your logic for creating new objects is getting, well, messy. If that sounds familiar, you are in exactly the right place. Today, we are going to untangle that mess with a really powerful tool, the factory method pattern.
So take a look at your own code for a second. I bet it's just full of the new keyword, right? I mean, that's how we make objects. But what happens when just calling new isn't so simple anymore? When creating an object suddenly gets really complicated?
Look, every program has to create objects. That's a given. But as your projects get bigger and bigger, the question isn't if you're going to create them. The real question is, where should that happen? Where does all that creation logic actually belong? That's the exact kind of problem that design patterns were made to solve.
So you might be thinking, why not just use new everywhere? It's easy. Well, here's why that can turn into a huge headache. First off, the logic to create an object can get super complex. Then, you end up copying and pasting that same complex logic all over your codebase. And finally, and this is the big one, what do you do when you need a different way to create objects in a different situation? It just becomes a total maintenance nightmare.
Okay, so to make this all a bit more real, let's picture this. We're building a national park simulator. It's a fun little program, and our main job is to create different animals to put in the park. Let's say we need dogs, cats, and ducks.
Okay, so let's say we write some logic to randomly create an animal, and we need that logic in, I don't know, 2 different parts of our simulator. What happens? We end up with the exact same block of code in 2 different places. You can see it right here. It's identical. And now, imagine you want to change how animals are created. You have to go on a treasure hunt through your code to find and update every single copy. That is just asking for bugs. So what's a common first step to fix this? Well, a lot of people naturally create what's called a simple factory. The idea is super intuitive. You just pull all that creation code out of where it's duplicated and stick it into one single class. And boom, duplication problem solved. It's a really great start for sure.
But here comes the twist. What if our simulation needs a brand new feature? Let's say, instead of just random animals, we need a balanced mode to make sure we get an equal number of dogs, cats, and ducks. How do we do that? All of a sudden, our neat little simple factory feels, well, really rigid. It's not flexible enough for this new requirement.
And this is where we get to the core idea. Think of the simple factory on the left as a brick wall. It's solid, it does one thing, one way, and that's it. But the factory method on the right, that's more like a set of puzzle pieces. It doesn't give you one single rigid way to do things. Instead, it defines a contract, an interface, that just says, hey, you need to know how to create something. And this lets lots of different classes step up and fulfill that contract, each with its own special logic.
So what does this actually look like in code? It's pretty straightforward. First, you define a common animal factory interface. It has one simple rule. You've got to have a createAnimal method. Step 2, you create your specialized factories, like a random animal factory and our new balanced animal factory. And they both agree to follow that rule. And here's the magic. Your main program doesn't care which factory it's talking to. It just says, hey, factory, create an animal, and trusts that the specific factory it has will do the right thing.
And that brings us to the formal definition. This one's from the classic Head First Design Patterns book. It says, the factory method pattern defines an interface for creating an object, but lets subclasses decide which class to instantiate. That last part is key. It's all about pushing that decision-making down the line, letting someone else figure out the details.
Okay, to really get this, let's break the pattern down into its 4 main parts, its 4 building blocks. The first one is called the product. Don't let the name fool you. This is just the common interface for the thing we're trying to create. So in our simulator, the product is the animal interface. It sets the rules for what any animal in our park should be able to do. Next up, we have the concrete products. These are the real deals, the actual classes that implement that product interface. So for us, our concrete products are, you guessed it, the dog, cat, and duck classes themselves.
All right, piece number 3 is the creator, and this is really the heart of the whole pattern. This is the interface or abstract class that announces, hey, there's going to be a factory method. For us, this is our animal factory interface, the one that declares that createAnimal method.
And finally, we have the concrete creators. These are the classes that roll up their sleeves and actually do the work.
They implement the creator interface and contain the specific logic to create the objects. Our random animal factory and balanced animal factory, those are our concrete creators. It's these 4 pieces all working together that give us this incredible flexibility.
Okay, that's enough about animals. Let's switch gears and see how this pattern can power up a totally different kind of app. Imagine you're building a classic asteroids game. A huge part of that game is, obviously, creating asteroids for the player to shoot. But here's the thing, you want the game to get harder as the player gets better.
So how does the factory method help us? Well, check this out. Step 1, you create an asteroid factory. Step 2, your main game loop just calls create asteroid over and over. But here's the really clever bit. Step 3, when the player levels up, the game starts passing a parameter, like difficulty, to that factory. Step 4, the factory sees that difficulty level and uses it to create faster, bigger, more dangerous asteroids. And just like that, the game gets dynamic and can scale to infinite levels, all without the main game loop having a clue about how those asteroids are being made.
So what's the big takeaway here? What should you remember? It's this. The factory method pattern completely separates the part of your code that uses an object from the part that creates it. That separation, that decoupling, is everything. It means you can add new kinds of things to create or even swap out the entire creation strategy without having to change the code that asks for them. It takes messy, complicated creation logic and turns it into clean, reusable, and seriously powerful classes.
And that leaves us with one last question for you to think about. Go take a look at your own projects. I want you to look for those spots where you have complex or duplicated or really conditional logic just for creating an object, because I bet somewhere in your code there's a factory just waiting to be discovered.